Okay, we're done with shear turbulence. We're moving on to mechanical turbulence, which is any turbulence that forms when the wind blows over the ground, over obstacles near the ground, and as a result it goes from laminar flow to turbulent flow, transitions to turbulent flow. And there are many different causes of mechanical turbulence. Small obstacles near the ground, but also rough terrain. And then finally, mountain wave or mountain flows. The wind around mountains can be thought of as mechanical turbulence. This PowerPoint will cover small obstacle and rough terrain turbulence, and there will be more PowerPoints for mountain wave turbulence. So small obstacles near the ground, of course, as the wind blows over those, the wind flow separates and it produces small vortices or eddies. So we're going to look at the factors that determine small obstacle turbulence and some characteristics and how to fly. So first, the factors, of course, size. Size is important. Here with turbulence, it's also important. And the taller the obstacle, generally speaking, the more turbulence you will find downwind and also above, and even for that matter, in front of the obstacle. Smaller obstacles, the turbulence tends to be less and also be closer to the ground and not as far downwind. Also, the shape of the obstacle, if the shape is more streamlined, then you tend to get weaker turbulence, but if it's a very angular type of structure, then you're going to get more flow separation and more turbulence. Also, the location of the obstacle with respect to the ground, where you're taking off or landing, determines whether you're going to get turbulence over the runway or at the departure end, or perhaps at the other end of the runway. So direction is very important. And then also speed is important. And the rule of thumb is the stronger the wind speed, the stronger the turbulence. Weaker wind speeds or light wind speeds will produce hardly any turbulence at all. As far as the characteristics, you just need to be aware that downwind of small obstacles, you're going to find a wake that develops as a result of the adverse pressure gradient. For those of you who had aerodynamics, you probably remember the adverse pressure gradient. And you're going to see turbulence even ahead of the obstacle as a result of kind of a bow effect, and also above the obstacle. As a rule of thumb, and you should remember this for the exam, you're going to get turbulence 2 times the height of the obstacle. So if an obstacle is 500 feet tall, a very large building, you can expect turbulence 1,000 feet above the obstacle. And then another good rule of thumb is 10 times the height of the obstacle downwind. So using the example again, if the obstacle is 500 feet tall, then you're going to have turbulence 5,000 feet downwind of the obstacle, which is approximately a mile. Fly, of course, you want to be mindful of where the turbulence is, and because of that, you want to plan your flight as far as takeoff and departure to rotate before you hit that turbulence and hopefully climb above that turbulence. You might want to use a little bit higher airspeed. We talked about that already when we discussed the changing in the angle of attack. You want to have a higher airspeed so that the eddies don't affect your angle of attack as much. Also, coming in for a landing, you want to maintain a positive control of the aircraft, which means coming in with a little higher airspeed. So you might want to add 1/2 of the gust factor, and also probably come in with power, because on windy days you're going to have a lower ground speed, which will mean that you won't be able to get to the runway. You'll have to add a little power to the end of the runway. And also the flap configuration. A lot of times under gusty conditions, you want to come in with partial flaps instead of full flaps for various reasons. Has to do with having a higher airspeed so that as you approach the runway, gusts won't affect your angle of attack as much. Also, with less flaps, you will have a higher pitch attitude than you will do with more flaps. And then finally, also coming in for a landing, it is a consideration when you have to flare. if you're not using that much flaps. So you need to visualize the wind. Look at the obstacles around the airport and try and visualize where you're going to get the turbulence. And then think about where you're going to land the aircraft when you're coming in for a landing based on that. Also, you can look at or listen to the ATSC to tell you how strong the winds are. And also look at the windsock and tell you. Remember, the windsock, when it's fully extended, is 15 knots. But there are other ways to get wind and direction information at the airport. And then, of course, this type of turbulence isn't necessarily always reported. It's not necessarily in the air mets. They only give you winds greater than 30 knots over the ground. But pilot reports are invaluable for this kind of.
And then, of course, you can use an airport diagram to figure out the obstacles around the airport. Try and visualize the direction of the wind and see if you'll get turbulence at over the runway. I remember in Casper, Wyoming, runway 21, there were very tall hangars, and anytime the wind was out of the south, we would get significant turbulence over the runway. Made it for exciting landings sometimes. So that's all I have for this little PowerPoint presentation. I hope you enjoyed it.